Hello guys, how are you doing? There is a one common mistake almost every software engineer do. This is how it goes. When you're in a college or when you do like your degree program, you learn queues and like list, stack, all those data structures, fundamental and everything. And then also you learning what is the difference between queues and a topic. Queues in first come first out and topic is a pub sub implementation and so on and so forth. Now you come into industry, you get a Kafka, RabbitMQ and ActiveMQ, all those message brokers to work with. Now you are trying to map what you have learned into these products. As a result, what happened, you don't get full spectrum of this product, full feature of this product. Why? Because you don't know exactly how to work with this product. Because you're trying to map your fundamental, topic, this is a topic, you just create a topic and you subscribe. Now you create a problem when you scale this application. Now your topic or a queue has multiple consumers. Now you're in a little bit trouble. Okay, today I'm going to solve that problem. So what I'm going to do is I'm going to teach you everything what you need to know to work with the Kafka. Right? Because Kafka is a so popular streaming broker, or message broker, whatever you call. And I'm going to teach you everything you need to know, how to design a solution with the Kafka, and how practically Kafka works, and how you should be prepared when you're doing the scaling and everything when you work with the Kafka. Before that, I have something to tell you. I'm telling this to you. Yes, you. You didn't watch my last video, right? You just opened the video and look, okay, what is his new haircut? And okay, skip the video for a few places and just close it, right? You didn't watch completely. Now you need to go back and watch that video and come to learn this, because otherwise you can't understand this. So please go back and watch that video. I mean it, right? If you watch that video, you will understand this very clearly. Okay, so let's go back and see how this works, right? So now if you get the Kafka, we discussed we can have a one topic and multiple partitions, right? Here we have employee topic and 3 partitions. And also you have here the consumer group as a project consumer group, and that consumer group has one consumer, single consumer. Now this single consumer taking messages from all these 3 partitions, right? Now we scale the application. When we scale the application, we add one more consumer. Now what happens is, right, so now one partition is pointed to this consumer. Now this consumer 2 listening to partition 2, but still consumer 1 listening to partition 0 and 1. But you can predict this, right? This is completely random, and then it depends on how this listeners and the topics are coordinate. But I'm just like, this can be consumer 1 listen to 0 and 2 and 2 go to the 1. Doesn't matter, but this is theory. So now you add one more consumer. Now you have a 3 partitions, 3 consumers, right? Now what happened? See, each consumer reading from each partition. Okay? And now what you do is you add one more consumer. You think, okay, I need to speed up this more. Okay, let's add one more consumer. Let's scale this more. Now what happened? Since you have only 3 partitions, your Kafka do not send messages to consumer 4. That means consumer 4 will be idle. If you add 5, 6, 7, all of them are idle. Why? Because Kafka has a rule. You can have maximum consumers in the consumer group to the number of one number of partition you have, right? It's maximum. So now, but the use cases we keep this consumer 4. Why? Because for example, let's say consumer 3 crashed or consumer 2 crashed. Then there is a one consumer already running. So then Kafka can immediately hand over the rest of the things to the next consumer, right? For given that keep it hot, sometime we can keep this consumer running, but you need to decide whether it's really valid use case for you or not. So now, but that being said, there's a one more use case like this. You may be open other consumer group, right? We are going to see this everything practically. We are going to open other consumer group to the same topic, right? Now what happens is, here in the first consumer group, you have 3 consumers. So they have each consumer to each partition. But in the consumer group 2, you only have 2 consumers. So the consumer 2 listening to 2 partitions and the consumer 1 listening to only 1 partition, right? So now how this consumer knows where, like from where do I take the messages and so on and so forth. So Kafka support retention. So that means they maintain something called consumer offset. Based on that, Kafka exactly know this consumer read from here and need to go to up to here and everything. So we are going to see this in demo, right? Hope you understand. The rule is number of consumers in a consumer group. This doesn't mean number of consumer groups, or this doesn't mean number of consumers across consumer groups, right? This just means number of consumers inside the consumer group should be equal or less than to the number of partition in the topic. Right, let's try to see this in practical, how this works, right? I'm going to quickly demo this. Let's create a directory saying Kafka demo, right? And cd Kafka demo, and let's init a project. So I'm going to get the default and I'm going to create a project, right? Okay, I got the project created. So let's open the project in Visual Studio Code. Right, so now I have a project here. So now what I'm going to do is I'm going to first install the client to talk to Kafka. Since I'm going to do this with Node.js, and I'm going to install a client for the Node.js, so I'm going to install npm let's say Kafka.js. Right, you can even install Kafka node if you want, but doesn't matter what you use. It's just a library, but each library carrying different features, right? So now first I'm going to do is I'm going to create a topic, right, on my Kafka, right? So I'm going to, because I'm running a Kafka on a Docker, right, Docker exec. So let me to create in the terminal, so then it will be easy you to see this, right? Docker exec -it, my Docker is a Kafka, and get the bash running. Okay, so I'm going to opt Kafka, that's where Kafka install by default, right? Go to the bin, right? So now I'm going to create a topic with let's say 3 partitions. Okay, I'm going to create a topic with 3 partitions, right? So Kafka topic, and then I need to provide what I'm going to do with this. I'm going to create my zookeeper is zookeeper Docker itself, and listening on port 2181 default port, and replication factor is just 1 because this is a local cluster. I don't need much redundancy. And partitions is 3. I'm going to create a 3 partition, and topic is employee topic. Okay, so let's create the topic. Okay, topic created, right? So now my topic name is employee topic, which has 3 partitions. So now I'm quickly go here, and I'm going to create a new file here called let's say producer, right? And I'm going to import Kafka from Kafka.js, and I'm going to speed up little bit because you don't need to like watch I'm typing here. Right, I just create the producer, right? Let me to explain this. I'm creating a new Kafka connection to employee service, just a client ID, and my Kafka broker is localhost 1992, which is because I'm running on the local. If you're getting this from your AWS, then you need to use that one here. And then you need to get the producer, and then I'm going to publish this. Publish method. In the publish method, I'm going to get a producer to connect, and then if there's any error, I'm going to log it. And now what I'm going to do is I'm going to create from like 1 to 10, and then I'm going to use the employee topic, and then I'm going to use a key. This is very important. We are going to learn something about this. And for now, I'm going to key this one, and then value would be employee name Nairobi and +1, because we are going to just see just a simple message, right? So now let me to write the consumer as well. Consumer.js, right? That's also I'm going to little speed up, so it's easy. I just need to take these 2 directly because it's the same thing, and then it will be not the producer but the consumer. And then now you can see I create the same listening to the same topic, subscribe to the same topic, And here from beginning I set as a true, right? And when I get a message, every message I'm logging the partition and the message offset. So this is, I'm going to show you something, and the message value, of course, right? So now what I'm going to do is, since I have already running this, right, I'm going to show you how this works, right? So let's see. Let's first run the consumer, right? I'm going to run node. If there's any error, we can fix it. Oops, that's an error. Okay, so it says I cannot use the import because I need to come here and go to the package JSON, and I need to tell this is a type of module. Okay, makes sense? I forgot it. So now let's go back and run it again, consumer. Now it says consumer group ID must be non-empty string. Okay, right. So now it says I must supply the group ID. Why? Because every consumer must belongs to particular consumer group, because otherwise that logic won't work, right? So now what I want to avoid is, when you see something like this, you just put something as a group ID, but you have no idea where this group ID used, why this group ID required to the Kafka. Right now we know group ID is required to Kafka because Kafka getting these group consumers for the group ID you giving, right? And then Kafka act based on that, right? So now what we can do is, when we create the Kafka consumer, you can pass group ID, right? I'm going to tell this is the employee group, right? Employee, let's say it's a project group because this is the consumer, this is a project group. Right, so now I'm going to, now we learn one thing and we are going to run this again. So now you can see here, right, if you clearly see this, you can see employee topic 0, 1, 2. That means it's 0 base index, right? 0, 1, 2. That means all three partitions what we created listened by this Kafka, right? This consumer, right? So if you go back to our presentation, right, so this is this use case, right? We create one consumer, so it listens to all three topics, right? Now see what happened, right? I'm going to open a new consumer, right? I'm going to create a new terminal, right? And I'm going to say where it is in the Kafka demo, right? So now I'm going to add new consumer, right? So if you go back here, see this carefully, right? See this carefully. So it says 0, 1, 2, right? Now see what happened is after this dash line. Okay, I go here and I'm going to run this one more consumer. Now you can see it only listened to 0 and 2, right? Now what happened to the first one? See this one, right? So now this is the where we left, right? This dash line. Now you can see this consumer only listened to topic 1, sorry, partition 1, right? Only partition 1. So now how many partitions we have? 3 partitions, right? We have 3 partitions. So now what I'm going to do is, I'm going to let's say I'm going to create one more consumer, right? So then I can demonstrate that too, right? Node consumer.js, right? And now you can see here this listen to partition 0, right? If you go here, this is rebalanced to use the partition 1, and if you go here, this is rebalanced to use the partition 2. You can see whenever you add consumer to the consumer group, Kafka automatically balancing it based on the number of partitions you have. Now can you predict, if you add one more consumer, what's going to happen? What's going to happen? Nothing. That consumer will be idle. Okay, before we go there, right, let's add the let's send some messages here. Okay, so now you can see here this key is completely dynamic, right? So now what I'm going to do is, I'm going to send this message, right? Producer. Okay, so now producer produce messages. Now you can see this consumer got 0, 1, 2, 3, right? This got 4 messages, right? This got 2 messages, right? That means altogether 6. This got other 4 messages. You can see the messages are balanced, the load balanced in between consumers, right? Messages are balanced in between consumers. Here we said act, we didn't set any act. If you set the act, it won't send the messages until you send the act back. But here, since we don't control the act, it just sending all the messages what it received, right? So now, do we have anything, if we add one more consumer, right? Let's say we add one more consumer, okay? We add one more consumer. So now you can see this consumer do not have anything, right, in the member assignment, right? It doesn't have anything. So now if I send these messages again, you will see the new consumer, which is the 4th consumer, will not get anything, right? See now, I send the messages, first one got, second one, these are like rebalancing because, right? So this one got, but this one don't have any messages, right? Now see what happened. I'm going to kill one consumer, right? I'm going to kill one consumer, okay? I'm going to kill this one, right? If you watch here, it will take little time based on the zookeeper heartbeat configuration. So after a little while, this will rebalance, right? This will rebalance because there was an active consumer gone. So ideally, this consumer need to get some assignment now, because this consumer can listen to for a partition now. See, now this consumer is listening to a partition, right? So now let's publish this again, right? Publish the same messages again. So now you can see this consumer is dead because it's not listening anymore. But interesting thing is this consumer who didn't receive any messages before, now receiving messages. Why? Because the one consumer dead, this consumer was hot, so then it assigned directly to this consumer, right? I hope this is clear now, right? All these use cases clear now. So this was the first case, or like one consumer, and this was 2 consumer case, right? Then this was 3 consumer case, which is balanced, right? We added 4th consumer, he didn't get any messages. Then we kill one consumer, so the 4th consumer got assigned messages, right? Why? Because there are no consumers anymore, because now you have idle consumer. Kafka is giving work to that consumer because he's idle, and then he can rebalance again. So now we have few more experiments to do, right? So let's rename this as producer, so that would be easy, right? So now I'm going to kill one more consumer, right? I'm going to kill one more consumer. Now only 2 consumers are here, right? Only 2 consumers are here. So now they will rebalance, right? They will rebalance. You can see that mean we have 3 partitions, 2 consumers. That mean one consumer should listen to 2 partitions, right? So we'll see how they do it, right? So now you can see this consumer listen to 0 and 2, then this may listen to just 1. Okay, so now let's see something like this. Now I'm going to produce the same messages again, right? I'm going to produce the same messages again, and you will see one consumer get more messages than the other consumer. Why? Because this consumer listening to two different partitions, right? But see this one, okay? See this one. Now what I'm going to do is I draw a line in between here and here, okay? See now what happened. This is so beautiful, right? So now what I'm going to do is, right, so this comes as like a key 12, okay. So now what I'm going to do is I'm going to use, let's say we go back here, 6 and 7, okay. So this got 2 messages, this got this messages. Now we have 2 consumers still, but I'm going to hard code the key, okay. Let's say EMP001, let's say we hard code the employee ID, right? EMP001 is the key. Now if I produce, right, what can happen? We learned this last video. If you remember, you can answer this. If we run this, what can happen? Okay, see whether your prediction was right. So now I ran the program, it generate 10. If you go here, this consumer got nothing, right? But if you get here, this consumer got everything. How this is possible? Because if you remember last video, I explained you Kafka guaranteed this partition based on the key. If you specify a key in your message, what the Kafka does is Kafka take this key and it has its own algorithm. It is not the number mod function, right? Modular function, but it do the modular algorithm, modular function, and then based on the modular results, Kafka decide which topic it should go. So therefore, if you need order guaranteed in the Kafka implementation, you need to make sure, let's say you want to process all the customers' orders in like the way they generated, right? So now if you can use a customer ID as a key. So now as here, you can see EMP001 was the ID. So since this is the same ID, it send that employee's record to the same partition, right? As a result, single consumer will take it. See how it works, right? One consumer always listening to one partition, and then consumer can listen to multiple partition, but the single partition only giving messages to one consumer, right? So now if you use something like a customer ID, employee ID, something like that, which you need to guarantee the order based on, you can send those messages there, and then other party will same consumer will process those messages, right? So this is the how you can guarantee the order. Keep in mind, Kafka do not guarantee order in between topics, in between partitions. I always miss the partition and the topics, right? Yeah, Kafka does not guarantee order between partitions. That means, let's say 10:00:00, exactly 10 o'clock, the customer 1 send the order, right? So we have a customer order, so it go to the 0 topic. Now 0 consumer will take it. If the 0 consumer is busy, the later message come into the partition 1 or 2 maybe get processed before the customer 1, because it's a 2 different partitions, right? But if you send a message to same partition, then order is guaranteed within that partition, right? So now what I'm going to do is I'm going to open the other consumer, changing the consumer group, right? This is a project 2 group, right? I'm going to change the group, and I'm set the beginning from beginning true. Okay, see now what happened. I'm going to get this dead consumer window itself, right? So now this is a new consumer, but the consumer going to start with a different consumer group. What you can predict. Okay, see whether your prediction was right. So now you can see that get all the messages from the beginning, right? You get all the messages from the beginning. Why? Because Kafka knows this is a new consumer group, right? So if you see this consumer group is listening to all 3 partitions. So that means whatever you send the message, it just hit the single consumer, right? Because it listens to all 3 partitions, so it goes to single consumer. So whatever you send messages to these 3 partitions before, now it's consumed by this consumer, right? So now I'm going to start other consumer, project 3 consumer, but from the beginning is false, right? From the beginning is false, right? I'm going to use this one, right? And I'm going to start this consumer. Now consumer started still listening 3 consumers, 3 partitions, but did not get any messages. Why? Because we said from the beginning is false, right? From the beginning is false. Okay, so let's do some different demo. I'm going to stop all this. So I kill all these trails, right? So now only have a producer, right? So now what I'm going to do is I'm going to create consumers in the 2 consumers in the project group, right? I'm going to create 2 consumers on the project group, right? So node, okay, this is the producer, right? Okay, so let's get the one more shell, and node consumer.js, right? So now is in the project group, and I'm going to get other consumer, and also is in the project group, right? So this consumer group is a project. So now as a result, he will listening to 2 and this will listening to 1, right? Yeah, cool. So now what I'm going to do is here, I'm going to create this group, the project 2 group, and I am going to open new consumer. Right? I'm going to rename this consumer saying P2 group consumer, and I'm going to run this. Right? This is the new consumer, and from the beginning it says it's a false. Right? So now see what happened. Right? I'm going to send the same messages again. Right? Same messages again, but the message will be ID would be random, right? So like this. So now let's see what happened. I produce the messages. If I go here, you can see this consumer only got 2 messages. That means this consumer should have get 8 messages. Correct, right? Correct. If you go here, he got all the 10 messages. Why? Because these 2 consumers in the project consumer group, this consumer is in the project 2 consumer group. That means since it's a one consumer on the project 2 consumer group, it listens to all the partition. But since this consumer is on the consumer, these 2 consumers for the consumer project consumer group, then they get the load balance. Right. So let me to reset the project. I need to show you one more thing. Right. So I'm going to reset this. I'm going to delete this terminals except the producer, right? So now I have the producer. I deleted everything. Okay. So now what I'm going to do is I demonstrated almost all use cases, but I have one more thing to go. So now how many partitions we have? 3 partitions, right? So now what I'm going to do is I'm going to remove this key. Okay, I'm going to remove the key. So that means the producer does not provide the key to Kafka. Right, does not provide the key to the Kafka. So now I'm going to create, so how many partitions we have? 3. So I'm going to create 3 different consumers. Right? So that means each consumer will listen to each partition. Okay, so they're listening from the different consumer groups. So I'm going to reset them back to project. Right, so now we have so now we have 3 consumers, so I'm going to run them. So node consumer, right? So now it's listening to all 3. Now it will balance again. Right, so now it will balance again. Right, now it will balance again. Right, so now you can see each consumer listening to each partition. Right, so now I'm going to produce message, right? I'm going to produce the message. See what happened. Okay, see what happened. So when I produce the messages, I have 10 messages produced. You can see first got 3 messages, second got 4 messages, and third got 3 messages. Why? Because when you divide 10 into 3, the 1 is remaining, so it distributed like that, right? So now what I'm going to do is I'm going to set these messages to 12. I'm going to publish 12 messages, right? To see the difference, I'm going to draw a line here. Right? I'm going to draw a line here. Okay, cool. So now see what happened. I'm going to produce this. So now remember, we don't provide any key. Right? So we don't provide any key. So now when you run this, if you go here, it get 4 messages. If you go here, it get 4 messages. If you go here, it get 4 messages. Right? So now I'm going to make this as let's say 15. Right? 15. Okay. So now see what happened. Okay. So I'm going to produce this. So now you will see each one get 5 messages, right? So the lesson here, if you provide the key with the producer, then it uses this mod algorithm and determine based on the key. So that means if you provide the same key always, it's guaranteed it's sent to the same partition. I mean, eventually it consumed by the same consumer. But if you do not supply the key, the Kafka do the round robin, right? The random round robin. It get 1, 2, 3, 1, 2, 3, 1, 2, 3, like that. If you get 9 messages, 3 partitions, each one get 3 messages, right? It's a round robin. But the problem here, then if it's same customer, one message go to the one partition, and second message may go to the second partition, third message may go to the third partition, like that, right? So then the in between, even within the same customer, between messages, order is not guaranteed. That's a disadvantage, right? But if you need the order guaranteed, you need to use the key. That is the last lesson I teach you. Right, I think I covered everything what you need to know about the consumers and consumer groups and also the partition, right? If I summarize everything, Kafka has a rule, number of partitions and the number of consumers. What is the rule? The number of consumers always should be less than or equal to the number of partitions within the same consumer group. Right? So you can have a multiple consumer groups. Those consumer group may have a different configuration, but what happens is in this coordination mechanism, what the Kafka do is, if you have one consumer but multiple partitions, this single consumer list do everything. When you add more and more consumers, then it will load balance within these consumers if they're the consumer group. The moment you create more consumers than the number of partitions, those consumers will be idle unless one active consumer dies, right? So now, what you take away? When you design a solution with a Kafka, you need to make sure how many partitions you are going to create, because that is very, very important. If you need order guaranteed, you need to supply a key, because it's a go based on the key. It decides which partition to go. Within the partition, order is guaranteed. So then consumer will take all the messages as this message is published to the key, published the topic, right? But within the partition, there are no order guaranteed. Okay, so now I think I did everything what you need. So now you can go to work with the Kafka as a pro. Remember, when you work with the Kafka, you need to make sure you design the solution upfront. You need to think, you need to plan how many consumers you're going to place when you have at the time you have the highest scaling, right? Because based on that you can decide how many partitions you create on the topic, right? Okay, so then see you in the next video. Make sure you subscribe that, and I'm sure you like this video. So why you don't click on this thumbs up? Click that. Okay, so click the thumbs up, put a comment if you are interesting, and also share this video, and I'll see you in the next video with an interesting topic. Stay safe. Take care.